Hello students, welcome to a new video. In today's video, we are going to discuss about refraction at the spherical surface. For this, we simply consider a spherical surface like this. This is a spherical surface. On the left hand side of the spherical surface, we consider a medium whose refractive index is n1. And on the right hand side of this spherical surface, we consider another medium whose refractive index is n2. So we consider a simple ray diagram for this in order to study the refraction at a spherical surface. Now we have a point object here. This is a point object O. From this we consider two rays emanating from this point object. So one ray is traveling along this direction and another ray is traveling along this direction. Now see, this ray is traveling along this direction. This ray is originating from the point O or the object O, and that ray is traveling along this direction. Now this ray is normal to this spherical surface or perpendicular to this spherical surface at this point M. So if a ray is normal to the surface at this point or on a spherical surface, then that ray will always travel undivided in the second medium after suffering refraction. Okay, so this ray is going along this direction. It is normal at this point. Okay, the incident angle in this case is 0 degree. So that ray will travel undivided in this second medium whose refractive index is n2. So we get a ray in this direction. Now we consider a second ray emanating from this point along this direction. So this ray is going along this direction. It is going and striking this spherical surface at this point, which is N. Okay, at that point, if we draw a normal perpendicular to the surface, normal means perpendicular to the surface. So if we draw a line, or if we consider a normal which will be perpendicular to the surface at this point, then that normal will always pass through the center of curvature of this spherical surface. Okay, always remember, for a spherical surface, if we draw a normal or a perpendicular at any point of the spherical surface, then that normal or that perpendicular line will always pass through the center of curvature for a spherical surface. So we are drawing this normal at the point at which this incident ray is going and striking the surface. So at this point, if we draw a normal in this direction, then that normal will always pass through the center of curvature. So we consider the center of curvature of this spherical surface to be C. Now this ray is going and striking the surface at this point. After striking the surface, this is a spherical surface, so it will undergo refraction because the refractive index of this medium is different, that is n1, and the refractive index of the second medium is also different, that is n2. Okay, so that's why this ray will suffer refraction at this point. After suffering refraction, it is going and passing through this point, or it is going and meeting the first ray at this point. So what will happen? We will get an image I of the object at this point. This is the object, and we get the image at this point, at which the two rays, after passing through the mirrors, after passing through the spherical surface or after refraction from the spherical surface, go and meet. Okay, so the point at which these two rays go and meet, at that point we will get the image I of the object O. Right? So we are going to perform a simple derivation for refraction at a spherical surface. So here we consider the incident angle to be I. Incident angle is the angle between the incident ray and the normal to the surface at that point. Okay, so this will be the angle of incidence, the angle between the normal at the point of incidence and the incident ray. That is the incident angle I. Which is the angle of refraction? Angle of refraction will be this one, because this is the normal and this is the refracted ray. So the angle between the refracted ray and the normal will be the angle of refraction, small r. Okay. Now we consider the center of this spherical surface, this point, to be M. R, capital R, is the radius of curvature of the spherical surface. Then U, small u, is the object distance. Object distance means the distance of the object from the spherical surface, and V is the distance of the image from the spherical surface. So now we will just begin the calculation or the derivation of this phenomenon. Now for this ray diagram, if we consider the angles to be very small, suppose if we consider this angle to be very small, then this ray will go and strike this spherical surface at a point somewhere here, right? In that case, what will happen? This point M will be very close to this point. Now what is this point? We have just dropped a normal from the point N on this ray, right? So we have just dropped a normal at this point on this ray. So here this point will be very close to this point if this angle is very small. So in that case, we can consider this point to be the point M, right? So we will not consider this M, we will just consider this point to be point M. So in that case, if we consider triangle NOM, if we consider the triangle NOM, in this triangle, what will be the value of this tan of this angle, right? We are going to take out tan of this angle, tangent of this angle. So that will be tan of angle NOM. Tan of angle NOM. That will be nothing but MN, which is the perpendicular, divided by OM, which is the base. Okay, so perpendicular divided by base becomes MN divided by OM for this triangle NOM. Now see, we have considered the angles to be very small. So if the angles are considered to be very small, then tan theta can be approximately written as theta, right? So in this case, theta is angle NOM. We have taken here tan of theta or tan of the angle NOM. This can be written as theta. That means this can be written as angle NOM, and that will be angle NOM will be equal to MN divided by OM. Similarly, for this triangle NCM, which is triangle NCM, this NCM. So for this triangle, what will be the value of angle NCM, or what will be the value of the tan of the angle NCM? This will be triangle NCM. For that triangle, if we consider tan of this angle NCM, then that will be equal to MN divided by MC. Now we have considered this angle, to be very small. So in that case, tan of NCM becomes angle NCM, and that is equal to MN divided by MC. Here MN is the perpendicular and MC is the base. So we get the value of angle NCM to be MN divided by MC. Similarly, for the third triangle NMI, for this triangle NMI, what will be the tan of the angle, this one? What will be the tan of the angle NIC or NIM? That will be equal to MN, which is the base, MN, which is the perpendicular, divided by base. So base is MI. Therefore, we get the value of angle NIM to be MN divided by MI. In this case also, we have considered a very small angle, this angle to be very small. So that is why we have considered tan of angle NIM to be approximately equal to angle NIM, which is nothing but MN divided by MI. Now see, in this diagram, we have seen that angle I is the exterior angle for this triangle. For triangle NOC, we can see that the angle I is the exterior angle, and we also know that the exterior angle is equal to the sum of the interior opposite angles. So what are the interior angles for this triangle NOC? For this triangle, this angle and this angle, or we can say angle NOM and angle NCM are the interior opposite angles. So angle I will be equal to the sum of the interior opposite angles. That means angle I will be equal to angle NOM plus angle NCM. Now if we substitute the values of this angle and this angle, then we get the value of I to be MN divided by OM plus, for this we have MN divided by MC. So the value of I becomes MN by OM plus MN by MC. Similarly, for the second triangle NIC, for this triangle NIC, in this triangle, this angle, the angle NCM is the exterior angle. Okay, so this angle will be equal to the sum of interior opposite angles. So in this triangle, this angle R and this angle NIC or NIM, these two angles are the interior opposite angles of this angle. Okay, so we can write NCM to be equal to this angle plus this angle. So we have written here angle NCM is equal to angle R plus angle NIC. Now this angle NIC can also be written as angle NIM. This is angle NIC, which is the same angle if we consider NIM. So we can consider NIC, angle NIC to be angle NIM. So I have written here NIM instead of NIC. So I have considered here NIM instead of NIC. Therefore, what will be the value of R? Now the value of R becomes angle NCM. We just have to take this angle to the other side. Then angle R will be equal to angle NCM plus angle NIM. For that, if we substitute the values of angle NCM and angle NIM, then we will get the value of small r to be Mn divided by Mc minus Mn divided by Mi. Now if we apply Snell's law here, then we will have sin I divided by sin r will be equal to N2 divided by N1. Here N2 is the refractive index of the second medium and N1 is the refractive index of the first medium. That means for which is the first medium? The ray in which the medium in which the incident ray is traveling is the medium 1, and for that medium the refractive index is N1. Similarly, the medium in which the refracted ray is traveling is the second medium 2, and for that medium the refractive index is N2. So sin I by sin r will be equal to N2 divided by N1. Now if you cross multiply N1 with this and N2 with sin r, then we will have N1 sin I will be equal to N2 sin r. Remember here one thing, sin I, we are taking the incident angle, so this is for the incident media. Okay, so in the medium in which the incident ray is traveling, we consider that refractive index to be N1 here. Okay, and this part is for refraction, so we can say that this part is for incidence N1 sin I, and this part will be for refraction N2 sin r. Right, this is a very important formula. You will require this formula in solving your numerical problems. Now if we consider the angles to be very small, we have already considered the angles to be very small, so in that case for small angles sin I will be almost equal to I and sin r will be almost equal to r. We can write I instead of sin I and we can write r instead of sin r. So therefore this formula now becomes N1I equal to N2r. We have written here I in place of sin I and r in place of sin r. Therefore N1I will be equal to N2r. Okay, now if you substitute the values of I from we have already derived the value of I. Okay, that was Mn divided by Om plus Mn divided by Mc. If we substitute that value in this equation, and if we also substitute the value of R in this equation, then we will obtain a very important formula. Okay, so here I have substituted the value of R, that is Mn divided by Mc plus minus Mn divided by Mi. Okay, we just have to substitute the values of I and R. So we have N1 into Mn divided by Om plus Mn divided by Mc is equal to N2 into Mn divided by Mc minus Mn divided by Mi. See here we have Mn in common, so if we take Mn outside, then this Mn will get cancelled out, right? So inside the brackets we will have N1 into 1 by Om plus 1 by Mc, that will be equal to N2 into 1 by Mc minus 1 by Mi. Here Mn gets cancelled on both sides. Okay, now if you multiply this N1 with these terms, then if you open the bracket, then this becomes N1 divided by Om plus N1 divided by Mc, that will be equal to N2 divided by Mc minus N2 divided by Mi. So this is the equation, right? If we bring N2 by Mi to the other side and transfer this part to the other side, then we will have N1 divided by Om plus, we bring this term here, N2 divided by Mi. Okay, that will be equal to, we bring this term to the right hand side. That means this will become N2 minus N1 divided by Mc. After that, we know that Om, what is the value of Om? Om is the object distance. Om, this is the object distance. According to sign convention, we take the object distance as u, and according to sign convention, this is taken to be negative. Okay, since we are measuring the distance from the center of the spherical surface, that means we will have to move backwards, right? We will have to measure backwards while the incident ray is traveling in the forward direction. So we will have to take the distance as negative. So OM will become minus U. Then what will be MI? MI, we are moving along the same direction as that of the incident ray direction. That means MI will become positive. So this is nothing but V. So which is the object image distance. Therefore MI will be equal to plus V, which is the image distance from the spherical surface. What is MC? We have MC here. What is MC? MC is this distance from M to C, or we can consider from here to C. That is the radius of curvature, capital R. Okay, and if we measure the distance from this point to this point, then we are measuring along the forward direction in which the incident ray is moving, right? So for that case, MC will be positive. So we have MC is equal to plus R. If we substitute these three values in this equation, then we have a very important equation, or a very important formula: N2 divided by V minus N1 divided by U, that is equal to N2 minus N1 divided by R. Okay, here N2 is the medium, is the refractive index of the medium in which refraction is occurring, right? N1 is the refractive index of the medium in which the incident ray is traveling. Okay, V is the image distance, U is the object distance, and R is the radius of curvature. So if you are given some numerical problems, then you will have to first see in which medium the ray is incident and in which medium the ray is getting refracted. Okay, for this case we have considered the refraction in the second medium and the incident ray is traveling in the first medium. Therefore we have got the equation like this, or accordingly we have got the equation here. N2 is the medium in which refraction is occurring. So sometimes if we take the opposite direction of the incident, if we take the incident ray to be traveling along the opposite direction from this point towards this side, then these two values will get changed. That means this will become N1 divided by V minus N2 divided by U, right? So we'll have to change, or we'll have to modify the formula accordingly. But in this case, since we have considered this medium to be N1 and this medium to be N2, so we have obtained the formula N2 divided by V minus N1 divided by U, that is equal to N2 minus N1 divided by R. This is a very important formula. You will require this for numerical problems, right? You'll have to solve very numerous numerical problems. Okay, so this is a very important formula. Please practice this and please keep it in mind. Thanks for watching.